Okay, welcome back to our Sui Move course. In this lesson, we'll dive into fungible tokens within Sui Move, provide an overview of the Sui framework, and introduce the weakness and capability design patterns. Lastly, we'll explore a managed coin example. Here is the agenda for today's lesson. We'll begin by understanding the concept of fungible tokens, followed by learning about the process of publishing fungible tokens on Sui. Alright, let's start with introduction to fungible tokens. In previous lessons, we have examined non-fungible tokens. Today, we shift our focus to fungible tokens. So in a blockchain, fungible tokens are cryptocurrencies like Bitcoin. Fungible tokens are characterized by three main features: divisibility, non-uniqueness, and interchangeability. So the first one is divisibility. Fungible tokens can be subdivided into smaller units, which allows for fractional ownership. And this granting transactions lends versatility to the token's utility and value. The second one is non-uniqueness. Tokens within the same category are homogeneous and share the same specifications. And lastly, we have our interchangeability. Fungible tokens can be exchanged for any other token of the same type. The common applications for fungible tokens includes cryptocurrencies, loyalty and rewards program, and cross-border payments. So for the fungible tokens on Sui, the Sui framework encompasses essential on-chain libraries for Sui Move developers. Using modules within the Sui framework, developers can create custom fungible tokens. Examples of such modules are coin and transfer. But before issuing a custom fungible tokens on Sui, it is imperative to understand the following concepts: generics, the weakness design pattern, capability design pattern, and Sui Coin. Okay, let's start with introduction to generics. Generics are abstract placeholders for concrete types or other properties. They offer greater flexibility and reduce code duplication in SuiMove. Generics are commonly used in library code, such as in Vector, to declare code that works over any possible instantiation. Here, we have two code snippets that illustrate the distinction between employing generics and not. Without generics, creating objects in new types necessitates an excessive amount of repetitive code. However, with generics, this redundancy can be bypassed, as one can directly impose the required type here. And here's two pieces of code that show the difference in functions using generics or not. By using generics, you can simply have just one function to declare any box type you want. And without generics, you have to have a new function for every new type. We can also add on constraints to enforce that the type passing to the generics must have certain abilities. Constraints empower us to define the attributes of these unknown types, thereby enabling the type system to sanction operations which might otherwise be considered risky. The codes provided cannot compile because the Go structure, as you can see here, lacks a drop ability. And one possible solution would be to add spurious ability annotations to the Go structure, but it will also lead to two problems. The first is that it will weaken the types with unnecessary ability declarations. It will also require function generics on the unused type parameter to also include the necessary constraints. And that's why we have the phantom types. So phantom types parameters solve this problem. Unused type parameters marked as phantom type parameter do not participate in ability derivation for structures, avoiding the need for spurious ability annotations. And let's examine an example to understand the application of phantom types. Consider a box that can store any structure with storage capabilities. However, if an ability lacks to be stored, the box cannot store it. And in such cases, designating T as a Fandom type can alleviate capacity constraint rules. If a type parameter is not part of the structure definition, or it is not only used as parameter of another Fandom type, then T can be declared as a Fandom type. So in our example, Boombox does not utilize the T type in its fields, making it safe to designate T as a Fandom type. And for a more comprehensive understanding of the Fandom keyword, you can consult the Move language documentation. Next, I'll introduce the witness design pattern. Witness is a pattern employed to verify the ownership of a type. A witness resource must be immediately dropped after use, ensuring that the same resource cannot be reused to initialize any other structures. And in the following example, the function of the GenType module creates an example of the MyType and calls the createCard function to create the instance of the car MyType type. The createCard function takes any type T with drop ability and creates a car object, ensuring a witness resource corresponds to a car instance. Where the witness resource is MyType, and the type we want to control the instance is car. The witness resource type must have the drop keyword so that this resource can be deleted after being passed to the function. And the capability restriction for the type parameter received by car is restricted to drop only. We see that the instance of the MyType resource are passed to the createCard method and deleted. That's ensuring that a caller has ownership of the witness and that only one instance of the car can be created for a witness resource. One-time witness is a special instance of a type which is created only in the module initializer and is guaranteed to be unique. In SuiMove, a type is considered a one-time witness if the definition has the following properties. The type is named after the module but uppercased. The type only has a drop ability. So this is a one-time witness example. We can find that the weights matches the two properties we just mentioned, and it is created in the initializer function. Now, let's talk about the capability design pattern in SuiMove. So capability is a pattern that allows authorizing actions with an object. So the following code is just an example of the capability that creates a box for an address. Only the user with admin cap can invoke this method. Okay, let's start learning the most important part of issuing a fungible token, the Sui Coin module. The Sui Coin module is a central library within the Stream framework, instrumental in the creation of custom fungible tokens on Sui. The resources and methods that we'll employ in our fungible tokens example include the coin metadata, the treasury cap, and all of them are resources. We also need the method coin create currency. Okay, let's take a look at the fundamental structures within the Sui Coin module. So coin metadata is the structure stores the metadata to a specific coin type, such as ID, decimals, descriptions, and blah blah blah. And coin is a coin of type T with associated values. The treasury cap employs the capability design pattern discussed earlier. Within Sui Coin, treasury cap grants the holder the authority to mint and burn coins of type T. The method create currency creates a new currency type T as a return and the treasury cap for generic T, as you can see here, the treasury cap and the coin metadata. It can be only called with a one-time witness type, ensuring that there's only one treasury cap per T. So, as you can see here, the method creates and returns two objects. One is treasury cap, and the other is coin metadata resource. The asserts here check that the witness resource passing one-time witness using the Sui type is one-time witness from the Sui framework. Here's two main functions. Users with treasury cap here, and also the treasury cap here, can invoke these functions to mint a certain amount of coins. And mint is just used to create a coin worth specified value. Mint and transfer is an entry function invoked from command line tool or SDK to create a coin worth value and transfer it to the recipient. Coin burn is used to destroy a coin, and users with the treasury cap can invoke this function. Coin join is used to consume the coin C and add its value to the self, as you can see here. So if you have two coins with value, you can join them to one coin. Here is split and take methods, the opposite methods of join and can be used to split a coin into two. Coin split is used to split the coin self into two coins, which is split amount and also the self. So the remaining balance left is just the self. And coin take is used to handle the balance. And the coin destroy 0 is to destroy a coin with value 0. You can view more methods of Sui Coin in the Mr. Labs GitHub repository here. As coin is an object with key on Sui, we use the Sui transfer public transfer to transfer a coin object to others. And you may have seen its usage in the coin mint and transfer function. Alright, let's do some simple exercises. So you'll try to implement a custom fungible tokens using Sui Coin with details below, such as the name should be Sui Coin, Sui Course Coin, and the symbol is SEC, and blah blah blah. And you can post here. And if you have done or if you cannot figure out how to do it, you can come back later to the example code. All right, you can start with your work. Okay, welcome back. So this is the example code. We define a module under the account fungible tokens. Then we import the dependencies from the Sui framework. And in the initialize function, we invoke the create currency with the one-time witness to get the treasury cap and also the coin metadata of the custom coin. Then we freeze the coin metadata and transfer to the publisher. So that's it. That's the end of this lesson, and I hope you enjoyed it. I'll see you next time.